All right, hello you guys. Welcome to our second to last module. We're almost done with the semester. The last things we have to talk about in Methods 1 is this week's module, reading experiment articles and correlational design, and then next week's module, which is on observational design, and then our course wrap up. And then we'll be doing some finals, and then we'll be done. So we are almost finished with the semester. All right, so here's what we're going to talk about in this module. We'll talk about reading experiment articles first. That is the Darley and Latine paper as well as the Loftus and Palmer paper that you guys read for the first homework that's due in this module. So we'll do a little discussion of these and some activities on them. And then we'll talk about correlational design. That's the other half of the homework that you did for this week's module. So we'll talk about bivariate correlations. We'll talk about interrogating association claims. And then we'll talk a little bit about moderators. Now, heads up, moderators, that's probably the most advanced topic in this course. I'm not going to expect you guys to totally understand moderators when you leave this course. Really, I'm just trying to give you kind of an overview of how moderators work so that when you see them in future courses, you'll kind of know what they are. And then we'll talk about what's next. So we'll talk about what to do for the last content module. That would be next week's module on observation, and then the course wrap up. And so let's go ahead and dive right into it. All right, so let's start by talking about the Darley and Latine article that you read. This one was about the bystander effect, one of the first demonstrations of the bystander effect. Very exciting stuff. All right, so what I'm going to have you do is we're going to practice our skills from chapter 10. That would be last week's module on experimental design using this paper. So what I'm going to do is I'm going to pose a couple of questions for you. Then I'm going to recommend that you pause the video and answer them. If you need to go look at the article to answer them, go do that, or just from your memory, either way. And then I will give you the answer so you can check your work, so to speak. All right, so here's the first question. What was the IV in this study? Here's my cat. She says hello. The second question related to this is how many levels were there of the independent variable and what were they? And then was the independent variable measured or manipulated? All right, there's my cat again. And then what was the DV? Was the dependent variable in this study? And then was it measured or manipulated? All right, so take a minute, pause the video, answer the questions, and then come back and hear the answers. All right, so hopefully that was enough time, so let's talk about the answers now. So first off, what was the IV? The IV in this study was group size or number of bystanders. There were 3 levels. That they were the 3 conditions of the study, 3 conditions of the independent variable. So one was the group size where the participant was alone with the confederate. There was no other bystanders. They were the only person. The second level, second condition, was the one where there was the participant, the bystander, the participant, the confederate having the seizure, and then one other bystander. And then the third condition, the third level, was the one where there was the participant, the confederate having the seizure, and 4 other bystanders. So those were the 3 levels, the 3 conditions of the independent variable. And was it measured or manipulated? It was manipulated. That's because the IV is the one that the researchers tamper with, the one that they mess with, right? So this is the one that Darley and Latine were manipulating. They were looking to see, right, in the cause and effect relationship, the IV is the cause. They were looking to see, does group size, does number of bystanders matter? So are people going to change their behavior based on how many other people there are when they hear or see somebody having an emergency? All right, so that was the IV. The DV then was helping behavior. So in the cause and effect relationship, the DV is the effect. It's the thing that we think is going to be affected by the IV. So in this case, the IV is group size, how many bystanders are there, and the DV is helping behavior. So Darley and Latine were trying to find out, does the number of bystanders present when somebody has an emergency, in this case when the confederate pretends to have a seizure, does that impact helping behavior? And of course they find that it does. So the more bystanders who are around, the less likely somebody experiencing an emergency is to get help. And if they do get help, it tends to be slower to come when there are more people around. And was that measured or manipulated? It was measured. So we never manipulate DVs. We always manipulate IVs. DVs are always measured though. So that means everybody has the same DV. They're recorded in the same way. The DV is constant across the conditions because we're looking to see, does changing the IV have an effect on the DV? So everybody, they're in these different levels. They have different numbers of bystanders hanging around. And the DV then, they all have the same opportunity to help. And the researchers then look to see, does the DV change based on conditions of the IV? All right. All right, now same idea here. I'm going to pose a couple more questions for you on this slide, then I'm going to have you pause the video and answer them, and then hear me talk about them to check your answers. So first question, was this an independent groups design or a within groups design, and how do you know? Secondly, which design was this specifically? So was this post-test only, pre-test, post-test, repeated measures, or concurrent measures? And then lastly, was there a manipulation check, and if so, did it work? All right, so take a minute, pause the video, and then come back when you're ready to hear the answers. All right, so was this independent groups or within groups design? This was an independent groups design. The reason that you know this is because the participants in this study, they only saw one of the three conditions or the three levels of the independent variable. They did not see all three of them. If this was a within groups design, then the participants would have seen all three of those conditions. They would have first had the Confederate experience the seizure over the intercom discussion when it was just them. Then they would have experienced it with one other bystander, and then they would have experienced it with four other bystanders. That's a within groups design. The participant sees all of the conditions. But as you hear me talking about that, you can probably see why it would be impossible or very bad idea to do within groups design for this study. And that's because once the participant has been in this situation of the fake seizure once, it's believable enough, right? But if they go then to do a second intercom discussion and they have the exact same experience just with one more bystander, there's a fake seizure again, they're going to be suspicious. They're going to be on to you as the researcher. They're going to know that that seizure is not real and that that's what you're studying in this experiment. And, you know, let alone when they experience it the third time. If they didn't know the second time, they're definitely going to know the third time. That's demand characteristics, right? That's order effects too. So that's a huge problem. And so I know a couple people mentioned in the exit ticket for the week 4 module that it's hard to tell the benefits, the pros and cons, or when you would use independent versus within groups design. This is how you tell. Neither of these design types is inherently better than the other. They both have advantages and disadvantages. But the big problem with within groups design is that you can't use it in situations like this, where participants are going to be suspicious once they're in multiple levels of the IV, multiple conditions. So that's when you would use independent groups instead of within groups, and that's why you'll read a lot of independent groups design articles, because often we have this problem. If participants are in more than one condition, they're going to know what we're studying, and they're going to give us modified data. They're going to change their responses because they know what we're studying. And we don't want that. We want people's natural responses. So if we have to do independent groups designs where participants only see one condition, don't even know that other conditions exist to preserve our data quality, then that's what we'll do. All right, so independent groups design, and we know that because they only saw one condition. All right, now which design was this of these 4 types? You can rule out 2 of them right away, repeated measures or concurrent measures, because those are within groups designs. We know this was not a within groups design, therefore it couldn't be repeated measures or concurrent measures. That leaves post-test only or pre-test post-test. Now take a minute and think, what's the difference between post-test only and pre-test post-test? All right, if your answer was that in one of those, in post-test only, they see the DV once, and in pre-test post-test, they see the DV twice, that was correct. So pre-test post-test, they do the DV first, then they do the IV, whatever the intervention is, and then they do the DV again in post-test. That's pre-test post-test. That's referring to seeing the DV twice. The advantage of pre-test post-test is that you can more accurately measure the change from pre-test to post-test. But of course, the downside of that is that if participants see the DV twice, they might get suspicious. So if you have people, you give people an opportunity for helping behavior, and then you have them, experience the person having the seizure, and then give them the same opportunity for helping behavior. Again, they might be suspicious that that's what you're looking at. They might modify your data. It might compromise your data quality. So pre-test post-test is great, but sometimes we really can't use it because we don't want people to be suspicious. So in that case, that would leave us with post-test only. And indeed, this Darling and Latinay paper, this was post-test only. They didn't do helping behavior twice, right? They dumped them right into the intercom with the fake seizure with the condition of the number of bystanders. So they dumped them right into the IV and then gave them the opportunity for helping. That was the DV. That makes this post-test only. So pre-test post-test versus post-test only, you want to think about, are they seeing the DV once or twice? That's how you tell the difference between those. All right, and then lastly, was there a manipulation check, and if so, did it work? Now remember, manipulation checks are little things that researchers can put into the study to see whether their manipulation worked. And that's because sometimes we don't know if our manipulation is going to be strong enough, or we're not sure about the construct validity. Is our manipulation really doing what we think it is? That's the value of a manipulation check. It helps us see, is our situation believable? Did our manipulation seem to work the way we expected it to? That's the point of a manipulation check. Now, there was a manipulation check in Darley and Latine, but it was subjective. It was where, if you look in the paper, you'll see that they report about the believability, the plausibility of the seizure, the experimental condition. And so they just subjectively asked people. They didn't have them rate like 1 to 5, it was believable. They just asked them, did you think it was a real seizure? And they found that pretty much everybody did believe it. So that's a little plausibility check, a little manipulation check. All right, that brings us to activity number 1. So for this activity, what I want you to do is interrogate the 4 validities for this Darley and Latine paper. Now, the point of this is to kind of bring together the things that we've been talking about throughout the semester. If you remember way back toward the beginning of the semester, we talked about 3 claims, 4 validities, right? And we've talked since then about the validities in a little more detail. So we talked about construct validity when we talked about measuring variables. We talked about external validity when we talked about sampling. And we talked last week about internal validity when we talked about experimental designs. As we talked about before, statistical validity, that's really more of your stats class. So we didn't talk as much about statistical validity, but we talked about the others a pretty good amount. So for this activity, you're kind of pulling that all together. You are going to first brainstorm 1 question for each of the 4 validities. So that's internal, external, construct, statistical, right? So first in part A of this activity, you're going to brainstorm 1 question for each of those. And you're just going to think of something that you could ask about this specific research study for each of those validities. So for example, we know what the point of construct validity is. How well did we measure something? So you're going to think about one of the measurements in this study and say, how well was that measured? And ask a specific question about that. And the same for the others. Okay, and then part B of this activity, you're going to search for answers to your 4 total questions and then write them down. So you're going to look in the article for answers to your questions. Some of your questions might not be answered in the article. That's okay. You just say you couldn't find the answer. But if you can find the answer, then you'll write it down. And then part C, after you've interrogated those validities, then think about whether you think the causal claim that Darley and Latine made about bystander intervention is justified. Now remember, the point of assessing validities is to think about the quality of the study, right? So for example, we know that this was an experimental study. They're making a causal claim. They're saying the more bystanders there are, the less likely somebody is to get help. That's the causal claim that they're making. And our job with these validities is to think about, the quality of the study. How well did they measure their variables? Were there any, internal validity threats, that kind of thing. And so what you're going to do after you've answered your 4 questions in parts A and B of this activity is then think about whether you think that causal claim that the more bystanders there are, the less likely someone is to get helped. Do you think that that's justified? And then you'll explain a little bit about why you think it is or why you think it isn't. All right, so that's your first activity. You know the drill for this by now. You'll type up your answers and then submit them in the activity number 1 submission portal in this week's module. So once you are done with that, come back to the video and we'll continue. All right, so let's continue on. Our second part of reading experiment articles is that we'll talk a little bit about the Loftus and Palmer paper that you read, which, by the way, is one of my favorite papers. I love stuff on memory reconstruction, so I hope you enjoyed this article as well. All right, so same idea here. I'm going to ask you a couple of questions about experiment 1, which you'll use the stuff that you learned in last week's module to answer. So I'm going to pose all the questions, and then I'll recommend that you pause the video, think about the answers, and then come back when you're ready to hear them. All right, so these are all about experiment 1 of our 2 experiment paper. So first off, what was the IV? How many levels in the IV were there, and what were they? Was the IV measured or manipulated? Then what was the DV? Was it measured or manipulated? Was this an independent groups design or a within groups design? And then lastly, which design was this? Post-test only, pre-test, post-test, repeated measures, or concurrent measures? All right, so same idea, pause the video, think of the answers, go look back at the article if you need to, and then when you're ready, come back and hear what the answers were. Check your work. All right, so for experiment 1, what was the IV? The IV was question wording. So they had everybody watch those videos of car crashes, right? Everybody watched the same videos. And then they asked people, hey, how fast were the cars going when they... and then the verb that they add into that sentence, that is the independent variable. They're changing what the word was, the verb phrasing, to see if that impacts people's memory of the accidents that they were watching. All right, so that was the IV. It was the question wording. It was the verb. There were 5 levels, so they had different versions of that question. How fast were the cars going when they hit each other, when they bumped each other, when they contacted each other, when they smashed each other, right? So 5 levels there of those different verb phrasings. And this was manipulated. So remember, IVs are the ones that researchers are messing with. IVs are always manipulated. So the researchers put people into conditions where they answered that question about how fast the cars were going, and they answered it based on one of those levels. All right, so what was the DV? The DV was the miles per hour estimate. It was the answer to that question of how fast the cars were going. And this was measured. DVs are always measured. Everybody gets the same DV question. They're all asked, how fast did you think the cars were going? Right? The phrasing of the question for, bumped, hit, contacted, etc., that was manipulated. But the question itself, how fast were they going? Everybody got that same question about miles per hour. They all gave a miles per hour estimate. So it was measured, just recorded their answer by the researchers. All right, was this independent groups design or within groups design? It was independent groups design, and that's because they only had one of those questions. It could have been within groups design if they had watched car accidents and then had a question, how fast were the cars going when they hit each other, and then watched car accidents and then how fast were the cars going when they smashed each other, right, etc., etc. But again, similar to the Darling-Latine paper, you can imagine if you had people go through all of those conditions, they would start to get a little suspicious that maybe you are altering your word choice in the questions, and so they might be onto you, might have demand characteristics, might have a problem. So it's usually simpler in that kind of scenario to do an independent groups design instead, where participants only see one of the conditions. All right, and then specifically, what design was this? Again, you can rule out repeated measures or concurrent measures because this is not a within groups design. That leaves post-test only, pre-test, post-test. Then you have to ask yourself, did they see the DV once or twice? And in this case, they only saw the DV once. They watched the car accidents, they had the manipulated question phrasing, and then they gave the miles per hour estimate. It would have been, to do pre-test, post-test wouldn't really work in this scenario because you would have to ask how fast the cars were going and then have them give their estimate, and then ask how fast the cars were going when they smashed each other and then give the estimate. And you can see that wouldn't really work in this case. So post-test only is typically what we do if pre-test, post-test will not work, and this indeed was a post-test only design. All right, now a couple more questions and then we'll get into the next activity. What was the purpose of having 2 studies in this paper instead of just one? So this is our first multiple study paper that we've read. We'll read one more for next week's module. But this was the first multiple study paper that we have read in this class. So what was the point of having 2 studies? What did this let Loftus and Palmer show? So think about it for a sec. All right, if your answer was replication, then that is correct. So this was a replication, right? In the first study, they tested a new question, and in the second study, they checked that they could get the same finding, and indeed they did, right? Slightly modified procedure, but they did get the same finding twice in a row. So let's just show replication, and as we know from the sampling chapter, or excuse me, the generalization and replication chapter, to be important, a study must be replicated, and therefore having 2 study papers like this, 2 or more study papers, allows us to show replication. So it let Loftus and Palmer check that they probably do have a real finding, they got it twice. All right, now which of the 3 types of replication was this second study? So take a second, think about it, go back to the paper if you need to. All right, so which of the 3 types of replication was it? It definitely was not a direct replication because they did not do the exact same procedure twice, right? They made some changes to it. In fact, it wasn't even a conceptual replication because they actually added something new. It was replication plus extension. They included this new additional variable, this new additional part of the study of whether people would remember there being broken glass or not. That was not in the first study. It was something new that allowed them to extend the original finding to find out something else that's interesting and new as well. All right, so that takes us to us activity number 2, Loftus and Palmer. So for this, it's another 3-part activity. You're going to answer these questions about the Loftus and Palmer study. All right, so first off, brainstorm one question for each of the 4 validities, then search for answers to your 4 total questions and write them down. So similar to the last one. Part B, after your interrogation, discuss whether you think the causal claim made by Loftus and Palmer about word choice biasing memory is justified. So same idea as activity number 1, just giving you a little extra practice with this process of interrogating a causal claim. And then part C, did the 2 studies from this paper have any internal validity threats? So for example, confound, selection effects, demand characteristics that we talked about last time. If not, discuss why. If so, brainstorm how you could repeat the study to solve them. Here's my cat again. She wants to be part of this video very badly. All right, so take a minute, do your activity number 2, and then once you have that done, go ahead and submit that to the submission portal, and then come back and we'll continue on. Okay, so a couple of things that I want to mention about internal validity threats before we forge onward to correlational design. What I want to mention to you is that in activity 2, I had you look for internal validity threats in the 2 studies for Loftus and Palmer. But I want you to remember is that published journal articles, which Darlene Latney and Loftus and Palmer are both published journal articles. All the articles you've read this semester are published journal articles. If you think back to early in the semester, we talked about how for psych research to get published, it goes through peer review. So that means that if a researcher submits their paper to a journal, it doesn't just immediately get published. Instead, the editor of the journal sends it out to a couple of other scholars who do similar research, but who are not affiliated with the author of the paper. And those peers review the article and they look for problems. They do actually exactly what you were doing in those activities, these 2 activities so far in this chapter. They look for validity threats. They look for construct validity problems, statistical validity problems. They look for internal validity problems, external validity problems. They look for all of those. And they think about whether, if they find any, they think about whether they affect the results, right? And then they'll maybe ask the author to, hey, maybe you need to do another study to solve this validity threat, or hey, maybe you need to address this as a limitation, right? And so they're doing that process of what you are doing before journal articles ever actually get published. So that means 2 or 3 other researchers have carefully read and critiqued a paper before it actually will get published. So those peer reviewers looked for internal validity threats, again, as well as other validity threats too. So that means that most of the time published articles, like the ones you've read throughout the semester, typically don't have clear internal validity threats. And that's because they've already been looked for in the peer review process. It's rare for a paper to go through peer review and still have big problems. They might have small problems, but they usually won't have big problems. Because that's what peer review is for. It weeds out those issues, makes sure that we're publishing good science, ones that don't have huge threats. If published articles do have threats to any validity, these are typically named in the discussion section as limitations. All right, so that's just something to keep in mind as you continue reading articles. When you're reading published articles, they've already gone through peer review, so you're unlikely to find big problems with them. That's why sometimes in methods classes or other classes, you'll get fabricated examples of experiments. Like if you think way back to the very first day of class, we did that really crappy experiment where we were looking at physical movement and memory, and I had you sit still and memorize words or tap your head and memorize words. Do you remember that? That was a fabricated experiment. That was really bad in a lot of different ways. That kind of thing would never get published, right, because it has too many threats. But it's a tool for us to be able to identify those threats if we do see them. All right, now a couple of bonus activities throughout these slides. These are, you don't submit activities for these, but if you'd like a little more practice, they're good things to do. So similar to this week as last week, if you do the bonus activity and you'd like a key to check your work, just let me know. I'm happy to send it to you. This one, there's a popular media article at the link here. Teenagers will eat healthily if they think they're sticking it to the man. Interesting stuff about psychological reactants. And you could read this little article and then think about what kind of experiment it was, what are the IV and DV, independent groups or within groups, and then can it support that causal claim. So if you'd like a little extra practice with these concepts, this is a good one to practice with. All right, so now let's talk about correlational design. So we talked last week and then in the first part of this module about experimental design, but let's talk a little bit more about correlational design. We'll start by talking about bivariate correlation. All right, so bivariate correlations. Correlational studies are very common in psych research. We talked last week module and the first part of this one about experimental design. Those are common, very common too, especially in social psych. But correlational studies are probably even more common than experimental studies. And that's for a lot of good reasons that you read about in the textbook and that we'll talk about. There's a lot of things that we want to study that we just can't study with experiments. And so correlational designs are a really nice alternative when we can't actually do experiments. So there's tons of variables that we might be interested in but can't manipulate in experiments, and that's when bivariate correlations or correlational designs really shine. So for example, say we're interested in depression. I can't make depression an independent variable. I cannot manipulate this, right? I cannot randomly assign some people to be depressed and some people not to. I just can't do that. Even if I could do that, it would be extraordinarily unethical, right? I can't make people depressed. That would be awful. I just can't do that. But if we couldn't do experiments, right, would we just give up on depression and say, well, I can't study this if I can't manipulate it? No, right? That would be ridiculous. That's still something that we want to know about in psych research, and for the field of psychology as a whole, we still want to know about depression, and so studying it with a correlational design is a good alternative. Similar ideas with things like personality. I can't randomly assign people to be extroverted or introverted. They are what they are, and yet personality is something that's important for us and interesting for us to study. Same idea with religious beliefs. I can't manipulate that, but it's interesting to study. Culture, right? If you're in cultural psych, I can't manipulate people's culture, but that's still incredibly valuable to study, etc., etc., etc. There's tons of examples we could give of variables that we cannot manipulate, but we still want to study. We still want to know more about. And that's where correlational designs shine. All right, now remember, we've actually talked about correlations before a couple of weeks back. Specifically when we were talking about reliability before spring break, we talked about correlations. So we talked about how scatter plots can show inter-rater agreement in reliability. So each axis is one rater's measurement, each dot is one participant observed by both of the raters. And then we talked specifically about correlation coefficients also being able to show reliability. It's a more efficient summary than scatter plots, and they can be used for inter-rater, test, retest, even internal reliability. We talked about the characteristics of correlation coefficients then too. So correlation coefficients can give us reliability information. That's a measurement question. But correlations can also assess the relationship between two different variables, not just, for example, two different raters' measurements of observing kids on the playground, for example. That's a reliability question. But correlations can assess the links between two totally different variables. So say I want to know whether depression and anxiety are associated. I can assess that with a correlation. That's an association claim, right? That's what we're talking about when we're talking about correlations. But the similar ideas that we talked about with these coefficients and reliability also applies in bivariate correlations and association claims. All right, so beyond showing reliability, correlations are very commonly used to analyze data from correlational studies. So for example, is depression related to anxiety? That's a research question I can answer with a correlation. Or does religiosity predict voting behavior? Again, I can't do an experiment. I can't assign people to be religious or not, but I can measure it and I can look for associations between religiosity and voting behavior. Or are political beliefs associated with social media usage, right? Again, I can't manipulate political beliefs, but I can assess it and I can look for an association between these two variables. All right, so let's review some characteristics of correlations. All right, now there are two characteristics of the correlation coefficient. Remember, correlation coefficient, that's R, that's the Pearson R correlation, the R value. And there are two characteristics of it. There's the direction, that's the sign, whether it's positive or negative. And there's the strength, that's the size of the number between -1 and +1. Now remember, correlations can only go from -1 to +1. If you have a correlation of +2, that's literally impossible. You can't have that. So it only goes between -1 and +1. So the closer the number is to 1 or -1, the stronger that correlation is. If you were going to put scatter plots, they would be basically forming a straight line. That would be like a correlation of 1. And the farther apart the dots are from the scatter plot, the more all over the place they are, that correlation value, the size of the number, is going to get closer to 0. So 0 means no correlation. They have nothing to do with each other. And then the sign, whether it's positive or negative, tells you whether as x goes up, y is also going up. That would be a positive correlation. Or as x goes up, y goes down. That would be a negative correlation. Now, you read about in the book, in the chapter for this week's module, that Cohen's guidelines for evaluating strength based on R, that can kind of tell you the effect size that a correlation has. So if an R is about 0.1 or negative 0.1, that's pretty close to 0, right? That's a small or a weak association. So they're associated with each other, the two variables, but not very strongly. 0.3 or negative 0.3, that's medium or moderate. And then 0.5 or negative 0.5, that's large or strong. Now, 0.5, right, doesn't seem objectively that big when the largest possible correlation is 1 or negative 1. But in reality, people are complicated. We know this. We talked about unsystematic variability in last week's module. We know that people are not all identical robots. We're all very different. There's lots of things that affect our behavior. And so when we get a correlation of 0.5 or above, we get really excited about that because it's really rare to see correlations of like 0.9 and above. If you see a correlation of like 0.9 or 1, that's telling you that you're kind of measuring the same thing twice. So that'd be like measuring depression with two different measures, right? That would be like reliability, right? But when we're looking at something like depression and anxiety, two different variables, when we get anything 0.5 and above, we get excited about that because that's pretty strong in our book. All right, so what does a positive versus a negative correlation look like? Take a minute and think about it. All right, positive correlation means that as x goes up, what does y do? Goes up, right? Positive correlation. Negative correlation, as x goes up, what does y do? Goes down, so opposite direction. So what value would an extremely strong correlation have? Take a minute, think about it. All right, so the value of an extremely strong correlation would be +1 or -1. Either of those are strong, either a perfect positive correlation or perfect negative correlation, +1, -1. What about an extremely weak correlation? What would a weak correlation be? Now, a no correlation at all would be an R of 0. But you can see here in Cohen's guidelines, an R of about 0.1 or -0.1, that would be a weak correlation. So the closer to 0 the number is, the weaker the correlation is. All right, now let's take a look at these scatter plot examples. We have actually looked at these before. We looked at these in the when we were talking about reliability before break, but let's talk about them now in terms of correlations again. All right, so there's 4 examples here, A, B, C, and D. I want you to think about which of these would have positive correlation coefficients. Then think about which of these would have negative correlation coefficients. Think about which of these has the strongest coefficient and which of these has the weakest coefficient. So take a minute and think about that. See if you can identify the answers to each of these questions, and then restart the video and we'll go over them. All right, so which of these have positive coefficients? That would be A and B. That's because as x is going up, so is y. It's also going up in A and B. Which of these have negative coefficients? That would be C. So as x is going up, y is going down. You can just see that the direction of that line is reversed compared to the positive correlation. Which has the strongest coefficient? That would be B. And that's because the dots are closest to being in a straight line. They're the closest together. Which of them, oh, you see my cat in the background. Which of them has the weakest coefficient? That would be, that would be D. Okay, so as I mentioned in the previous slide, the weakest coefficient would be D, and that's because if you look at those dots, they're kind of all over the place, right? They are not very close together at all to form any kind of a line. Here's my cat once again. All right, so let's ask a couple of different questions about these correlations. All right, so here's the actual coefficients for these correlations. The question now is which is which. So take a minute and see if you could identify which of these graphs each of these correlation coefficients goes with. All right, so if we look at the first correlation, R equals 0.93, that would be a strong correlation. It's almost the perfect one, right? And it's positive, so as x goes up, so does y. The best fit for that would be B, because those dots are very close together, right, in that positive correlation. Second one, R equals 0.01, that would be D, so 0.01, that's close to 0, and this 0.01, right, D, these dots are all over the place. It would be hard to decide if you were going to draw a line going upward or downward. You could do it either way, and that's a pretty good indicator that these two variables, x and y, don't really have anything to do with each other. They're pretty much uncorrelated. And then the third one, R equals 0.56, that's positive, pretty strong, but not as strong as the first one. So that would be A. So those dots are, they're not really forming a perfect line, but they're going upward, and you can definitely see where you would draw that line. And then lastly, R equals negative 0.59, that one would be C. It's the only negative correlation here as X goes up, Y goes down. And it's moderately strong. I mean, it's strong according to our Cohen's cutoffs, but it's not a perfect line by any means. And voila, there they are. Okay, so let's continue. All right, next let's talk about interrogating association claims. So we just earlier when we were doing the reading experiment articles, you did 2 activities where you were interrogating those causal claims. Let's talk a little bit about how we would interrogate association claims like those produced by correlational designs. All right, when we are interrogating association claims, construct validity and statistical validity are the most important of the 4 for us to assess for association claims. So construct validity, right, that's that idea of are you measuring what you're supposed to be measuring? So how well were the variables operationalized or measured? That's a relevant question for association claims. Pop quiz, how many variables are there in an association claim? There are 2, right? So 2 things that are associated with each other. We would interrogate construct validity for each of them. So we would ask for each of those 2 variables, how well were they operationalized, how well were they measured? And to do this, you can think back to basically everything we talked about in chapter 5. So good operationalization, reliability of measures, those 5 subtypes of construct validity. If we're going to review these, right, operationalization, that's turning it from a conceptual variable to a operationalized one, to what you're actually going to measure or manipulate. That would be kind of like if our conceptual variable was, say, helping behavior, and we operationalize it by having people, experience somebody else having an emergency and then see do they go help them, right? That'd be like the operationalization of the DV from the Darling-Latine paper. Turning it from what you want to know about, which is kind of vague, helping behavior in that case, to what you're actually going to do in the study, which is very specific in terms of your methodology, like have people, hear somebody experiencing a seizure and then measure how long it takes for them to help. That's your operationalization. You would ask yourself, is this a good operationalization? Should we have operationalized helping behavior with something else instead? Like maybe, seeing if they donate to a charity, something like that, right? One conceptual variable can have many different operationalizations. You as a researcher have to decide what you think is a good operationalization of your variable. And then reliability of measures, that's all about consistency, right? So, inter-rater, internal, test, retest, consistency of the measure, does it give you the same results each time? And then those 5 subtypes of construct validity we talked about in chapter 5. Remember, you don't need to know them all specifically, but some of them are subjective, like face and content. Some of them are empirically tested, like criterion, conversion, and discriminant. Those are all ways that we can assess the construct validity of measures. So these are questions that you can ask about construct validity for association claims. Say that we are looking at the association between depression and anxiety. You can assess the construct validity both for your measurement of depression and for your measurement of anxiety. Are they good operationalizations? Are they reliable measures? Are they do they have construct validity in those 2 measures? You can ask questions about those for both of the variables in your association claim. All right, for statistical validity, you read about this in the textbook. There's a couple different things that you can assess for this. Now remember, as we've talked about before, this isn't a stats class, so you don't need to know these exactly, but I'm going to do you a quick little talk through of these 5 different kind of things that we can look at for statistical validity for association claims. All right, the first one that we can talk about is effect size. We talked about earlier when we talked about bivariate correlations, how 0.1 is a small or a weak association, 0.3 is a medium one, and 0.5 or above is a strong association. That's effect size, right? And the reason that those are getting at effect size is because the number of the correlation, 0.1, 0.3, 0.5, etc., that's indicating how close the dots are to the line of best fit, right? Like this example from the textbook, height in centimeters at age 18, plotted from height in centimeters at age 2. You can see if you look at that line of best fit, those dots are all pretty close to that line. It's basically forming that straight line. It's a positive association. If we were going to calculate the correlation coefficient, it would probably be something like 0.8, I would guess, maybe even higher. And that's effect size, right? That's showing us, oh, it's a really strong effect. It's a strong correlation. That's what effect size is for correlations. How strong is the correlation? Whereas the one on the bottom here, this is son's adult height plotted with mother's height. You can see by looking at these dots, they're kind of all over the place, right? It's not nearly as strong of an association as height from age 2 to age 18, this son's height and mother's height. So this is a much weaker association. This is probably like 0.4, something like that, maybe 0.5. So that's effect size. It tells you how strong is that association, how strongly are they linked together. Now, if you looked at the graph in A here, if you know the height at age 2, you can guess what the height at age 18 is going to be pretty well based on that line of best fit, right? So if you look at the graph here, it's saying Hugo's 2-year-old height, 83 centimeters. Hugo's predicted height, 172 centimeters based on that line of best fit. His actual height, 170 centimeters, very close to that. So you're only off by a little bit. That's a strong effect size. That's what a strong effect size does for you. It means you can predict one from the other pretty well. Not perfectly, but pretty well. If we try to make that prediction with the bottom graph, Hugo's mother's height, 163 centimeters, the line of best fit says his height is probably 174 centimeters, whereas actual height is 170. That's off a bit more. But you can look at some of these other dots. If we tried to predict them, they would be way off. If we look at the one that's at the top here that's cut off a little bit, if we made a prediction from the line of best fit for that person, it would be way wrong compared to what their actual height is. So that's what a lower effect size means, weaker correlation, not as good, not as well able to predict one from the other. All right, so that's effect size. Statistical significance then is just looking at whether it's a statistically significant correlation. That's an inferential test. You learn about that in stats. If you have a significant correlation, it means there's a real relationship between the variables. They are actually linked to each other. If you have a non-significant correlation, that means there's not a relationship. They have nothing to do with each other. And so that's an inferential test you can run to see are they actually related to each other or not. And again, in your stats class, you'll learn more about that process. The next thing that affects statistical validity is outliers. So outliers are dots in your scatter plot that are way outside of the rest of the pattern. They don't follow the rest of the pattern. And that happens sometimes in your data. So if we look at these two graphs here, A and B, these two scatter plots, they're in your textbook as well. If you look at A versus B, there's only one different dot between them. That's the dot that's the x4, y is about 14 or 15 or so. It's the dot that's in the top right corner of the A graph, and that dot doesn't exist in the B graph. But other than that dot, they're basically the same. And you can see how different the correlation is just based on the inclusion of one outlier, right? In A, the correlation is 0.15. That's a weak correlation, has a small effect size. But B, basically the same pattern, but without that one other dot, that one outlier, now we have a correlation of 0.49. It's medium. It's almost a strong correlation. That one dot that's outside of the pattern can change the correlation a lot. And so outliers can affect your statistical validity. All right, now restriction of range. This is a little tricky. The idea here with restriction of range, think about range as referring to whatever you have on your x-axis of your variable. And if you have a restriction of range, that means you're not measuring the whole range of possibilities. You're not measuring that entire variable. You're just measuring one small part of it. If you look at this example, also from the textbook, this is looking at SAT score and college grades. So you are supposed to take the SAT or the ACT. The reason that you're supposed to take that as part of your college applications is because SAT score is associated with college grades. So it's like a kind of like a proxy for colleges are trying to predict how well you're going to do in college, and they predict that based on your SAT score. Not a perfect measure, but we talk all about that. But this example shows you what restriction of range might look like. So here we have an example of a college that only admits students with scores above 1200 on the SAT. That's the A graph on top. So you have restriction of range. Then you're looking at SAT scores and college grades for people, but you only accepted people who have over 1200, and in that case you only have a moderate association, R equals 0.33, right? because you've restricted your range. You're missing part of that X variable. Whereas if we had included people who score below 1200 on the SAT, you'd have a much stronger association. So with that restriction of range, you've got the entire range of the X variable now on this bottom graph. The correlation there is 0.57. It's a strong correlation. That's restriction of range. It's a little tough to get your head around, but just think of it as you're not measuring the entire variable. You're missing some of that data. That can mess with your statistical validity, can make your association appear larger or smaller than it really is because you're missing part of that data. All right, and then curvilinear. This might be the easiest one to get your head around, curvilinear relationships. This is what a curvilinear correlation looks like. If you look at this graph here, we have age in years on the x-axis, use of the healthcare system on the y-axis. At 0 years, so when people are newborns, right, pretty high use of the healthcare system because they're probably being born in hospitals, they have to get vaccinations, they have to get checkups, all that stuff, right? They're in the healthcare system a lot. As people get a little older, right, look at the dots around age 20 and even around age 40, pretty low use of the healthcare system. 20s, 40s, etc. Those are usually years when you're pretty healthy, for the most part, right? Don't maybe have a lot of like healthcare needs. But then as you get older again into the 60s and the 80s, now our use of the healthcare system goes back up because now we're experiencing more health problems and we need more care and attention. So it's a curvilinear relationship. It's not a straight line. If I tried to draw a straight line through this, it wouldn't really capture this relationship because it's got a curvilinear. If you're going to draw a line through the dots, it would look like the mouth of a smiley face, right? That's a curvilinear association. Now the issue here is that R, the correlation coefficient, doesn't assess this. It only looks at linear relationships. R cannot assess curvilinear relationships. So if I put this data into the correlation coefficient equation, it would give me something like R equals 0.01 on the bottom here. That would make it seem like there's no relationship between age and use of the healthcare system because it's R close to 0. But really, it's just saying that there's not a linear relationship. There is a curvilinear relationship. So that affects your statistical validity too. If you just calculated the correlation coefficient and did not graph your data, you would think that they had nothing to do with each other. When really they do, it's just a curvilinear relationship. You have to graph it to see it. All right, now again, right, statistical validity is maybe a little tough to talk about in this class because you might not have had stats yet. I'm not expecting you guys to be experts in these 5 aspects of statistical validity for association claims. I'm just mentioning them so that if you have had stats before, you can kind of see how this applies, or so you can have an idea that these things matter, even if maybe you leave this class and maybe you don't remember what restriction of range means. That's okay, I'm not worried about that. Just keep in mind that these things are things that we can assess for statistical validity of association claims. All right, now external validity is sometimes important and sometimes it's not. When the focus is on generalizing, so if the purpose of your association, your correlational design, if the purpose is to generalize, then external validity matters a lot, right? And if you think back to when we talked about sampling, ways that we can improve external validity, that would be things like getting a random sample, right? It's how, not how many, that matters for external validity. If your research question is about generalizing, like for example, maybe I want to know, are depression and anxiety related among elderly people, and are depression and anxiety related among Latin American people, right? Those are questions that are about generalizing, then external validity matters a lot. But often the focus is not generalizing. Often it's just finding a psychological phenomenon. So in that case, it's just, is depression and anxiety related? Not necessarily for whom does that relationship work. The question is just, are they related at all? And if that's the focus, then external validity is not as important. These phenomena often do generalize, even if mean differences are very different. So for example, I think the book talks about how if there's an association between multitasking likelihood and skill, so like how often you multitask and how good you are at it, we're all on average pretty bad at multitasking, but if you do it more, you might be a little better at it. If that link exists, it's probably true for people of any age, even if means might be lower. So maybe older adults are worse at multitasking likelihood and multitasking skill, but even though they're worse at it on average than younger adults, that link is still probably there, that the more you do it, the better you are at it. All right, so external validity is sometimes important, sometimes not. Same idea we talked about before. It just matters on whether you're in generalization mode, your focus is on generalizing, in which case it matters a lot, or whether you're in theory testing mode. You're trying to just find a psychological phenomenon, in which case it's not as important. All right, now our fourth type of validity that we could interrogate for association claims is internal validity, and this is really important. By definition, correlational studies do not have internal validity. They just don't. We cannot make causal claims from correlational studies. We just can't. We know that right off the bat that we cannot do that. Correlation does not imply causation. You can never make a causal claim from a correlational study design. You just can't. And this is, we talked about this before, this is one of the biggest mistakes that journalists make when they're writing about research results. They take a correlational study and write a headline that implies causation using those causal verbs. And that's a big mistake because you cannot do that. So this is an incredibly important concept in psych research. You've probably heard this in your other classes. If you haven't already, you will in the rest of the psych major. Correlation does not equal causation. Correlation does not imply causation. What I want you to do, take a minute, write this down a couple of times in your notes. Put stars around it, circle it, right? Draw arrows toward it. This is a really, really important concept in this class and in the psych major as a whole. It's the biggest mistake popular media articles make when describing psych research, as I mentioned before. And sometimes even psych researchers get it wrong. And so that's why I want you guys to get it right. So put this in your notes a couple of times, circle it, star it, make sure that you remember this. Write it down one more time for good measure. Make sure this is in your notes. Really, really important concept in this class and in the psych major as a whole. So correlation does not imply causation. All right, now here's why correlation does not imply causation. If we look at our three causal criteria, covariance, temporal precedence, internal validity, we talked about these last week in the experimental design module. These cannot all be met with association claims. Let's take them one at a time. If we look at covariance, do the results show that the variables are correlated? Correlational studies might show covariance. So if there's a significant correlation, right, that we do a hypothesis test and we see, oh yeah, these two things are related to each other, that is covariance. So A is related to B, depression is related to anxiety. We can meet that criteria for covariance. But correlational studies may or may not show temporal precedence. So temporal precedence, that's the directionality problem. Does the method establish which variable came first in time? This is often a big problem with correlational designs. If I'm measuring depression and anxiety and I find that they're related, I don't know which one came first. I don't know whether people are depressed first and then they get anxiety, or whether people are anxious first and then they get depression. I don't know that from this design. I have no idea what came first. So correlational designs typically cannot show this. There's a couple of examples that we could talk about here, right? There was, which may or may not show temporal precedence. So there's a study that was in your textbook on meeting your spouse online versus in person. That actually, even though it's a correlational design, that actually does show temporal precedence. Because what it did is it looked at, it asked people, did you meet your spouse online or in person? And then how satisfied are you in a relationship? That actually does show temporal precedence because you have to meet your spouse before you can be in a relationship to be happy or not, right? So meeting your spouse does come before relationship satisfaction, so that does show temporal precedence. However, things like the depression and anxiety example I gave earlier doesn't, or this new one, correlating extroversion and conscientiousness. I don't know which one came first, and my correlational design won't tell me that. So that's why we say they may or may not show temporal precedence. It depends on the design. So the meeting spouse one, you do have temporal precedence, but most other correlational designs don't. And again, if these three causal criteria, if you can't meet even one of them, then you can't infer causation. You can't establish causation. You have to have all three in order to establish causation, and correlational studies can't. Now, number three, the third criteria, this is the one where correlational studies are always in trouble. Correlational studies cannot show internal validity, no matter what. So that's different than temporal precedence. May or may not be able to show it based on the design and the research question. But internal validity, we cannot show that with correlational designs. And that is always true for correlational designs. We cannot show internal validity. So this is the third variable problem. Is there some third variable that's associated with both of the ones that we're looking at independently? So that's like the C in this little graph here that could be causing both A and B. In correlational designs, there is always the possibility of a third variable. We cannot rule this out. We have to run a true experiment in order to rule it out, because that's where we can control everything except for the IV that we're manipulating. But again, it's not always possible to do that for correlational studies, so we have to just keep that in mind. You might have heard this example of the third variable problem. It's a real-world correlation that ice cream sales and homicides are correlated. I'm not making that up. That's true. Ice cream sales and homicides are related in the real world. If we were going to assume causation, we would say, oh, when you buy ice cream, it makes you kill people, or after you kill someone, you really need some ice cream, right? But that would be a mistake, because it's not that one's causing the other. Something else is causing both of those independently. There's a third variable that's causing them both. Maybe you already know the answer, maybe you don't. The third variable in that example is temperature. So when it's summertime, when it's really warm outside, that causes more ice cream sales because people want to cool off from the heat. And that separately, independently, also causes, temperature also causes homicides. Because when people are uncomfortable, they lash out more, they're more likely to do things that they wouldn't in cooler weather if they kind of had their head. So in that case, temperature is causing both of those things independently. It would be a mistake to say that one causes the other of ice cream sales and homicide, because really something else is causing them both. That's the problem with internal validity and correlations. You never know what a third variable might be. If we find that depression and anxiety are related, maybe one caused the other, or maybe something else caused them both. We can't determine that from a correlational design, and because we can't determine that, because we don't know, that's why we can't establish causation from them. We would have to do a true experiment to find that out, and again, sometimes that's just not possible. All right, so I hope you get this down in your notes, why this matters, why it's important. All right, and here's our third activity, looking at these three causal criteria. So this is our third activity for this module. I have the graph reproduced here for easy reference, but for each of the following media headlines that are all reporting on correlational studies, but the headline doesn't sound like it's correlational, brainstorm whether you could design a true experiment to establish the three criteria for causality. What would you need to do in your experiment to test causality? So there's three here, A, B, and C. Extra screen time drags down grades, giving kids sips of beer turns them into teenage drunks, and a new prescription for depression, join a team and get sweaty. So these are all headlines that are written in causal terms, but they are reporting on correlational studies. So your job is to see, could you design a real experiment that would test these causal criteria? So for example, for A, extra screen time drags down grades, how could you design a study that would establish covariance, that those two variables are related, that would establish temporal precedence, that extra screen time comes before grade change, and then internal validity that would rule out alternative explanations for the link, for the covariance between those two variables. All right, so same as usual, grab a new document, type up some answers to this, and submit it, and then come back and we will finish up. All right, so the last thing we're going to talk about in this module is moderators. And I see we're already at almost an hour with this module video, so I'm going to really just go through this very briefly. And that's because, again, this is an advanced idea. So if you listen to the next couple minutes and you're like, yeah, I got that, that's super awesome, that's fantastic. If you listen to the next couple minutes and you're like, I don't really get this, that's okay. I'm not that worried about this. I probably won't even really ask you about moderators on the final exam. I might have if we had been in a regular face-to-face class, but given the difficulty of learning online, we're just going to kind of skim through this, and you'll probably hear more about these later in your psych degree. All right, moderation, for a quick little overview, moderation happens when the relationship between two variables changes based on another variable. Moderation is an interaction. So you might hear it termed called an interaction effect when you're reading research articles, or when you're in methods too. All right, so here's an example of a moderator. Say that we find that the association between deep talk and well-being, this is from the textbook, is stronger for women than for men. The relationship between deep talk and well-being, that's an association, right? These two things are related to each other. But the second part of the sentence, it's stronger for women than men, that's the moderation. It's saying the relationship is changing between those two variables based on some third variable. So what are the three variables involved here? Deep talk is one variable, well-being is another. Those are two things that are associated with each other. The third variable that changes that relationship, that acts as a moderator, is gender. So it's stronger for women than for men. So gender changes that relationship. It changes what it looks like. So which one is the moderator? I gave that away. It's gender. And it changes the relationship because that association between deep talk and well-being, it's stronger, so it would have a correlation closer to 1, I would guess. It's stronger for women than for men, so it's weaker for men. Stronger for women, weaker for men. So it's changing what that relationship looks like. That's what a moderator does. It takes an association between two variables and it makes that association different. Maybe it makes it stronger for some people than others. Maybe it makes it go away for some people and exist for other people. It might even reverse it, so it's positive association for some people and negative association for other. That's what moderation is doing. It's changing what that relationship looks like. So one thing you can think about with moderators is this phrasing depend on. So the relationship, the association, it depends on some other variable. What that looks like depends on the other variable. So like this, stronger for men than women, it depends on, stronger for women than men rather, it depends on gender what that relationship looks like. All right, a little more moderator practice if you're interested. If you're not, you can skip this. I'm not going to be offended. So say that we know that number of daily stressors is associated with lower well-being. Many possible moderators could change this association. The fact that daily stressors is linked with lower well-being. Lots of other variables could change what that looks like. It could make it stronger versus weaker, could make it exist versus go away, could reverse the effects, etc. So for example, maybe social support plays a role. That could be a moderator to that relationship. Maybe at lower social support, more daily stressors is linked with lower well-being. But at higher social support, daily stressors maybe is not linked with well-being. So what that's saying is that social support could be changing that relationship. If you don't have much social support, you don't have many close friends that you can rely on or family, right? Then daily stressors is linked with lower well-being. But if you have a lot of social support, lots of friends and family you can rely on, maybe daily stressors doesn't affect your well-being. So you see it's changing that relationship. It's changing what it looks like. So the link between daily stressors and well-being depends on social support. It's there for some people, in this case, lower social support, but it's not there. It's not associated for others, in this case, higher social support. All right, if you would like to do this, you can brainstorm some more possible moderators and think what's the link between daily stressors and well-being at high levels of the variable versus low levels to give yourself a little practice with this idea if you're interested in that. All right, so let's go ahead and wrap up. All right, so here's the homework for next week, which again is our last content module. This is homework number 18. It's your last homework. It's a two-parter. The first part is from chapter 6. Note the page numbers. You're skipping the first section on survey construction. You're going to start at page 165 in chapter 6. Answer a couple questions about observational design, and this will be posted in next week's module. And then part 2 is to read your last research article of the semester. This article actually has 3 studies in it. It's a little bit longer than the other ones I've had you read, but I think you're gonna like it. I like this article a lot. It's looking at a very real-world problem of territorial driving. If you have ever, been trying to get a parking spot or you've been trying to leave a parking spot and somebody's like hovering behind you and you're like, oh, calm down, I'm almost out. If you ever had that experience, this article will be very interesting for you. So I hope you'll enjoy it. And then in our next module, we'll talk about this article some more. All right, so next week's module, last week of content. Again, we're talking about observational design, and then we'll do some course wrap-up. All right, so that brings us to our exit ticket for module number 5. So same as usual, clearest point, muddiest point. And as usual, for the muddiest point, let me know whether you'd like me to address it in a video or not. And then that wraps up this module. So make sure you've submitted everything. There are 3 activities for this module and the exit ticket, as well as 2 homework assignments. Quick note, by the way, there's 1 additional extra credit homework assignment. That's to read and answer some questions from chapter 9, which is like advanced correlational designs. That is purely optional. If you are not feeling it, you're not in the mood for it, it's a little bit of an advanced topics in that chapter. If you're not feeling it, skip it. It's totally fine. But if you do want to read a little more about advanced correlational designs, if you do that homework, I'll give you some extra credit for it. All right, that's it for today. So I hope you guys found this useful. If you have questions about anything, just let me know or post in the discussion board. And then I'll see you virtually next week for our last module.